My name's Michelle Thompson, and I am a planetary scientist. And specifically what that means is that I study planetary materials. That means any rock that has come from another planetary body. So I study samples that have been brought back from the moon by the astronauts and the Apollo missions. I study samples from asteroids, and I study samples from comets. And I study all these samples to try and understand what their composition is. What are the elements and the minerals that make up these rocks, and what can that tell us about the solar system? How did the solar system form? How have the planets across the solar system evolved over the last 4.5 billion years? And so I get to study how the solar system has evolved through the analysis of planetary samples. One of the things I do as part of my job is I'm a member of the science team for a NASA mission, which is called OSIRIS REx. OSIRIS REx was a mission to an asteroid. These are rocks that are floating out there in space, not as big as planets like Earth or Venus, but they are really relics of the early solar system. So they're the leftovers, rocks that didn't make it into the terrestrial planets that we think of, like Mercury and Venus and the Earth. And so by going to an asteroid and returning samples back to Earth so that we can study them here in our laboratory, it's like taking a time machine back to the earliest days of the solar system, 4.5 billion years ago. These rocks have not evolved at all. Here on Earth, we've got volcanoes, we have things like plate tectonics that are changing the surface of the Earth and changing the rocks on Earth all the time. But asteroids have been the same for the last 4.5 billion years. So by studying those rocks, we get a window into the early solar system and what the building blocks were for planets like Earth. So when I'm looking for people to work in my group, I want people that are good at working in the laboratory. So if you've taken a class in chemistry or physics and you do those laboratory experiments, that's what I'm doing all the time, but trying to analyze these planetary rocks. So people who are interested in understanding the chemistry, what the molecules are, the elements that make up these rocks, and what that can tell us about their history in the solar system, that's great. People who like working with real samples that have been returned from other planetary bodies. And then people who are good team players, because science is a team sport and we don't do anything on our own. So if you're interested in working as part of a really vibrant group, working with your hands in the lab, this is a good place to start.